In the part one video, we looked at what was an inverse function. Now we're going to look at how do I find the inverse function of a given function. So we're going to be given a function and we're going to be asked to find the inverse. So as we saw previously, the inverse function exchanges the x and y values of a given function. Similarly, we will switch the x and y variables of a given function and solve for y to find the inverse function. So we just have to follow these four steps right here, and each step is fairly simple. First thing we'll do is replace the function notation with y. That's just kind of to make the process a little bit easier. So once we do that, then we're going to interchange the x and y values and then solve for y. And then once we've done that, we need to replace the y back to function notation, but now it's the inverse function, so we need to make sure we include the proper notation. Okay, so like I said, each step is fairly simple. So on part A right here, we're just going to go ahead and change that f of x to a y equals 2x minus 3. Pretty simple. Okay, step 2, interchange the x and y. So wherever you see a y, change it to an x, and wherever you see an x, change it to a y. Okay, that's step 2. Step 3, solve for y. Okay, this should be fairly simple. So let's see, we'll start by adding 3 to both sides. So I get x plus 3 equals 2y. And then I'm going to divide by 2 on both sides. And so let's see, I end up with x plus 3 over 2 is equal to y. And then the last thing I want to do is indicate that this is the inverse function. So I'm going to use my inverse notation. F inverse of x is equal to x plus 3 over 2. And there is my answer. So not too bad. Just have to do a little bit of algebra and solving for y. That'll probably be the hardest step right there, is step 3. And for part A, it was not too bad. Example B does get a little bit trickier. So let's go ahead and try that one. So the first thing we'll do here is we'll replace the f of x notation with y equals 4 over 3x plus 7. And then what we want to do is interchange x and y. So now we're going to have x equals 4 divided by 3y plus 7. And so now we have to solve for y, and that can get a little tricky here. And so what we're going to do here is I typically ask students, do y'all like fractions? And they always say, no, we don't like fractions. So what we can do here is to get rid of a fraction, you multiply by the LCD, which in this case is going to be 3y plus 7. So I'm going to multiply both sides by 3y plus 7. Okay, and what will happen here is that will cancel out that fraction on the right side. And then on the left side, I'm left with 3y plus 7. And then I need to actually put that in parentheses. I should have put it in parentheses here also, because it needs to distribute with the x. Now I can distribute, I don't have to though. And so remember, my goal is to solve for y. So my first step basically got rid of the fraction. That's nice. But now I'm actually going to basically create a fraction again here if I want to divide both sides by x. But the good thing is whenever you're solving for a variable it's in the denominator spot, that's, you've got to get it out of there. And so that's why I multiplied both sides by the LCD. So here on this next step right here, I'm going to cancel out these x's, okay? And I'm going to swing up here where I have more room. And so then I have 3y plus 7 equals 4 divided by x. Okay, not bad. And now I just need to finish solving for y, which should be pretty simple. So what I'm going to do here is subtract by 7. Okay. And then now I'm left with 3y equals 4 divided by x minus 7. And then what I have to do here is divide both sides by 3, or what I could do, and this might make a little bit more sense, or might visually make it a little bit easier, I'm going to multiply both sides by 1/3. I'm going to multiply both sides by 1/3, and what will happen here is the 1/3 times 3 will cancel out to just a y. And then here I have to multiply both of these by 1/3. So this become 4 over 3x minus 7 over 3. And there we go. I solve for y. And so then my function notation, f inverse of x is equal to 4 over 3x minus 7 over 3. And there we go. Now, going back over here where I divided both sides by x, I could have distributed the x, and my answer would actually look a little different, but it would be equivalent. And so I'm just going to go ahead and take a moment to show you that real quick. So if I would have instead decided to distribute the x, I would have had 3yx plus 7x equals 4. And then I would have subtracted 7x from both sides. Okay. And that would cancel out. And I'd be left with 3yx equals 4 minus 7x. And then last, I would have divided everything by 3x to solve for y. So the 3 and the x would cancel out right here and here. And I'd be left with y equals 4 minus 7x over 3x. And so my answer looks different, but it's actually, these two things are equivalent right here. Because if I would have gotten an LCD right here between 3x and 3, I would have basically put an x here and here and brought this together as 4 minus 7x all over 3x. Either one's going to be correct, though. You can put either one when you're doing your homework, or if it were the exam, either one would be counted correct. And so maybe this one was maybe a little bit easier, but either way, it will work. All right. So the good news is that's about as bad as it's going to get. Okay. So example B, yeah, it was a little challenging with the algebra, but we got there. But moving forward, we shouldn't see anything quite like this. This should be a little bit easier to work with. So looking at example C right here, we've got f of x equals the cube root of 4x minus 5. And so once again, first step is change that to a y equals the cube root of 4x minus 5. And then now we have to interchange x and y. So the y becomes x equals cube root of 4y minus 5. And then now I want to solve for y, and I'll be done. So what I'm going to have to do here is to remove the cube root. What I'm going to have to do is I'm going to cube both sides. So I'm going to raise both sides to the power of 3. And so that will become x cubed equals, and then the cube root and the cube power nullify each other, and I'm left with 4y minus 5. And then from here, that should be pretty simple to solve. So let's see, we'll add 5 to both sides. So I get x cubed plus 5 equals 4y. And then we're going to divide both sides by 4. And that's going to be it. So let's see, that cancels out. So x cubed plus 5 divided by 4 is equal to y. And then our function notation, f inverse of x is equal to x cubed plus 5 over 4. So that one hopefully wasn't too bad. Okay, example D is kind of like C, but we're going to go in the other direction. Instead of having a cube root, we have a cube. So same thing with all these. We're going to change that to a y equals x plus 4 raised to the power of 3. And then this time, well, first we got to interchange. So let's interchange. So let's see, x equals y plus 4 to the power of 3. Okay. And so instead of instead of cubing, we are going to cube root both sides. So we're going to take the cube root of both sides. So I'm left with the cube root of x equals, and then the cube root's going to cancel with the cube power and leave me with just a y plus 4. Okay, that's not too bad. And then last but not least, we're going to subtract both sides by 4. Now be careful here because you have the cube root of x and then minus 4. So make sure that minus 4 is not part of the cube root, okay? So especially when you're doing your homework, when you type this in, you have to arrow to the right and then continue and type minus 4. If you don't do that arrow to the right, it's going to include it as part of the cube root, and you don't want to do that. And so then let's see, last but not least, our function notation. So we got the cube root of x and then minus 4. All right, so we got a couple more of those. So here we are. This looks pretty similar to what we were just doing. So let's see, we'll change that to a y equals x cubed minus 1. And so then we interchange. So then it's x equals y cubed minus 1. Okay, so what's going to be a little different about this one is before I can cube root, I need to go ahead and add the 1 to both sides first. So then let's see, we're going to have x plus 1 equals y to the power of 3. And then now we're going to cube root both sides. So we're going to cube root. So that plus 1 does become part of the cube root right there. And so we're left with the cube root of x plus 1 is equal to y, because the cube root and the cube cancel out. And there we go. And then the last thing I'll do is insert my function notation for the inverse. And there we are. Okay, example F, pretty similar. We got a little bit more algebra that will have to take place, but pretty similar example to E. So we're going to change this to y equals 7 times x cubed minus 12. We change out the x and y, so now we have x equals 7y to the power of 3 minus 12. And then before we take the cube root, we're going to have to isolate the y cubed. So you add 12 to both sides. X plus 12 equals 7 times y cubed. Then divide the whole thing by 7, and I'll kind of swing up here. So let's see, and I'll jump my y cubed on the other side. So y cubed equals x plus 12 over 7. And then now it's time to cube root both sides. And there we are. So y is equal to the cube root of x plus 12 over 7. And then if we want to do our function, inverse function notation, there we go. All right. Okay, these next couple, the algebra is not going to be too bad, but we have to be a little careful because of restricting the domain on some of these. So right here, we're going to be asked to find the inverse, but when we find the inverse, we're also going to have to restrict the domain. And so I include a graph here so we can kind of visualize this a little bit. And so just a reminder from our first video that whenever you graph these, they are a reflection of each other across the line y equals x. And then also they switch values. So like this ordered pair right here is at 0, -3, then you have -3, 0. Or at 1, -1, now it's at -1, 1. So that you're flip-flopping the x and y. So for my ordered pairs here, x and y, they're the same ordered pairs over here, but y is now my x and my, I'm sorry, yeah, my x is now the y value and the y value is now the x value. So they interchange. Anyways, that will maybe help us with these problems right here on finding the domain. So I'm actually going to graph this first. So hopefully you remember from transformations, this is just the square root function, and we're going to transfer to the right 4 units. So I'd go to the right 4, and so this would be, let's see, 1, 2, 3, 4. This would be what it would look like right here. So that right there is the original function f of x. And so we're going to be trying to find the inverse of that. So for example, this ordered pair right here was at 0, 4. Now it's going to be, I'm sorry, it was at 4, 0. Now it's going to be at 0, 4. It's going to be up here. And then this point was at what, 5? This was at 5, 1. Now we're going to be over 1, up 5. And so on. This was at 8, 2. Now it's going to be at 2, 8. And so the function we're going to be looking for is this blue one right here. That's going to be my inverse right there. And so I'm going to have to restrict that domain, because if I don't, then you'll see when I get my equation, I'm going to have this other part of it. And I don't want that, because remember, to have an inverse, both functions have to be that one-to-one. They have to be one-to-one functions. So let's go ahead and find it real quick, and then we'll talk about the domain. So we'll change this to a y equals the square root of x minus 4. And then now I have to square both sides. And so let's see, we get y squared equals, so then this is going to be x minus 4. The square root gets canceled out. And then, oh, very important, I forgot to swap the x and y values. So I'll just do that now. I should have done it earlier, but let's see. So that's x squared equals y minus 4. And then last thing we'll do here is we'll add 4 to both sides. And so we end up with y equals x squared plus 4. Okay, so that's going to be my inverse function, but the problem with that is if you were to graph the whole thing, it would have the little dashed part right here. And the problem is that that's not part of the original function, right? I don't have it coming around like this down below. And first of all, that wouldn't even be a function if it was, right? It wouldn't pass the vertical line test. But for a function and its inverse, they both have to be one-to-one. So what we're going to have to do here is limit my domain on this. And so my domain is going to have to be x values from 0 to infinity. So that's just kind of one of the little extra steps we're going to have to include on this, is to restrict that domain. So let's try another one. I've got a couple more of these, and once again, I have the pictures here. If you just make a little graph, it's going to make your life a lot easier. And so if you look at this one's going to cause us to go left 2, and then we have a reflection right here. We have a reflection across the x-axis. All right, so if you remember those 3 key points, they're originally right here, those 3 key points. So we're going to go left 2, and then reflect across the x-axis. And so that's where those 3 points are going to be right there. And so what's going to happen is when I graph this, it's actually going to kind of open down like this. All right. And so for my new function, the x and y values are going to get switch the order of them. So -2, 0 is now going to be 0, -2. And then -1, -1, well, actually that's going to stay right there, because when you swap them, it's still -1, -1. And then 2, -2 is now going to be -2 up 2, so it's going to be right here. And so if you were to look at this, this is going to be the graph of that one right there I have in red. Right there. So this is f of x. This is going to be the f inverse of x. So I can already tell what the domain is going to be. It's going to be x values less than 0, right? Less than or equal to 0. But let's go ahead and find the inverse algebraically now. So the f of x, we're going to change that to y equals the negative square root of x plus 2. And then let's swap the x and y. I forgot to do that at the beginning of the last one. So let's see, x equals negative square root of y plus 2. And so um, that negative, I can kind of ignore it because I'm going to square both sides. And so when I square it, it's going to get rid of the negative because squaring the negative turns positive. And so I'm going to end up with x squared equals just y plus 2, just like that. And so the negative, like I said, just kind of goes away. There's an understood negative 1 in front. And when you square it, it becomes positive. And then the last thing I need to do is subtract 2 from both sides. So I'm going to end up with x squared minus 2 equals y. Or if I'm using my inverse function notation, like that. And then last but not least, the domain. And so see, you kind of have to be careful. Basically, the domain is the range of the original function. Just like how the x and y values switch places, so does the domain and range. So another way you could look at this is just what's the range of this purple line right here? Well, it's from um, from 0 and it goes down to negative infinity. And so that's what this is going to be. So actually, you got to put negative infinity first, though, and then 0, and we'll bracket that in. So that's going to be the domain right there. So actually, that would be another way of figuring this out, is just find the range of the original function. So like if you go back up here, you can see that the range on this one goes from 0 and then up to infinity. The range on this one is from 0 to infinity. And that's what the domain's going to be of the inverse, because they just swap. And then if you look at what the domain is of this, that's what the range is of this. So let me just kind of show you that real quick. So if you want to find the domain of this is from 4 to infinity, right? The domain is from 4 to infinity. And that's actually what the range is of this. The range of this one goes from 4 and then up indefinitely to infinity. So that's another way you could do that. That would probably make life a little bit easier, actually, is just finding the range of the original, and then that's going to be the domain of your inverse. Okay, I think I might have one more of these. Let's see. Yep, I've got one more. So once again, let's go ahead and graph this, and then that's going to help us with the domain of our inverse when we find that next. So I'm going to have to go to the right 3 and then up 2. So take my points, I'm going to go right 1, 2, 3, up 1, 2. So that first point. Then to the right 1, 2, 3, up 1, 2. Then I had a point right here to the right 1, 2, 3, and then up 1, 2. So here is the original function. Here is the original function. That's going to be my f of x. And I'm going to go ahead and graph the inverse anyways, just to get some practice, because that's actually what that's the last thing we're going to do in a minute, is look at doing that. So let's see, 3, 2. So this was at 3, 2. So we're going to swap it to 2 up 3. Then let's see, this was 4, 3. Now it's going to be 3, 4. Then this point right here was at what, 7, 4. Now we're going to be at 4, 7. And so there we go. That's going to be the f inverse right there. Now, what's the range of f of x right here? What's the range? Well, let's see. The range, remember, it's the y values. It goes from 2 and then up. So it's going to be from 2 to infinity. So I can tell you right now, that's what the domain is going to be for this. That's going to be what the domain is for my f inverse function. Okay, so now it's time to find that inverse function algebraically. So we're going to change this to a y equals the square root of x minus 3 and then plus 2. And so we're going to go ahead and do the switch. X equals the square root of y minus 3 plus 2. And then let's see, now we have to solve for y. So since I don't want to square both sides yet because the plus 2 is not part of the square root. So I got to start by subtracting both sides by 2. So let's see, we're going to get x minus 2 equals the square root of y minus 3. Now I'm going to square both sides. So let's go ahead and square both sides. And so now I've got x minus 2 squared equals y minus 3. And then I need to go ahead and add 3 to both sides. I'm kind of running out of room. I'll come up here. So I'm going to have y equals, I'm going to have the x minus 2 squared, and then I have the plus 3 right there. And if you remember parabolas, remember this is the parabola, shape 1. So this is telling me to go to the right 2 and then up 3. And so when you take that parabola, that bowl shape right here, and you move it, it puts you right here. And the thing is, if I don't restrict the domain, then I'm including this part right here. So I have to restrict that domain. So the domain is going to be from 2 to infinity. And so once again, the easy thing might be is to find the range of the original function, and the range of the original function will be the domain of that inverse. Oh yeah, let me do my inverse notation. Okay, so I don't have much left to do, but I try to keep these videos under, around 20 minutes, and I'm way over. So I'm going to go ahead and stop here, and I'll start at part 3, and part 3 will be really short.